Hello students, today's lesson is more ratios. The first part of this lesson is ratios with more than two parts. So here we have some flags, as you see, red, green and blue flags. If we count them, we have 9 red, 6 green and 3 blue flags. So we can say that the ratio to green to blue to ratio of red to green to blue flags is 9 to 6 to 3. Well, because of the greatest common factor of 9, 6, and 3 is not 1, so it's 1, it's 3. That means we can simplify by 3. So if we simplify everything by 3, 9 divided by 3 it's 3, 2 divided by 6 divided by 3 it's 2, and 3 divided by 3 it's 1, we will get this ratio 3 to 2 to 1, which is exactly the same ratio as 9 to 6 to 3, just simplified. The next question here, it says, what is the ratio of blue to red to green? Alright, so we just need to rearrange the flags. Remember, the order is very important. So there are blue flags, so 3 blue, 2 red ones, well, red ones are 9, 2 green ones, well, green ones are 6. So again, we can simplify by 3. That means the ratio is 1 to 3 to 2, which is the same answer as the previous one, just reordered. Let's move on to another question. A bag contains 50 bars of chocolate. 25 of them are milk chocolate. So 25 milk chocolate. 15 are dark chocolate. And 10 of them are white chocolate. 10 of them white chocolate. So work out the ratio of white to milk to dark chocolate. Pay attention the order. So white to milk to dark chocolate. Well, white chocolates are 10. To milk chocolates are 25. To dark chocolates are 15. So if we find the greatest common factor of 25, 15 and 10, it will be 5. So the greatest common factor is 5. That means we can cancel everything by 5, or we can simplify everything by 5. So we will have 2 to 25 divided by 5, it's 5. 2 to 5, 15 divided by 5, it's 3. So 2 to 5 to 3. Let's move on. The second part of this lesson is ratios containing units. Sometimes we won't just make ratios out of pure numbers, we will have also some units with them. So let's see. Nelson measures 2 pieces of wood. One of them is 75 centimeters long and the other is 2 meters long. What is the ratio of their length? Remember, before you make ratio between these 2 pieces of wood, we should set them to have same unit of measurement. In this case, either we should make both of them in centimeters, either convert both of them into meters. So let us convert everything into centimeters. So the first piece of wood is 75 centimeters. Well, that's good, it's done, 75 centimeters. The second one is in 2 meters, but we can't leave it like that, so we can write 75 centimeters to 2 meters are equal to 200 centimeters. Well, now we can just convert this ratio to 75 to 200, and then somewhere here find the greatest common factor of 75 and 200. Well, it is 25. Now, the greatest common factor of 75 and 200 is 25. That means we can divide both of them by 25 to simplify this ratio. So 75 divided by 25, it's 3, and 200 divided by 25, it's 8. So the ratio is 3 to 8. Let's move on. Now we're starting with some exercises. The first exercise is we have some flags. In each case, that's given here, A, B, C, D, and E, write down the ratio to red flags to white flags to black flags. So red to white to black. We're going to solve only one of these. So under A, let's see, red flags, we have 1, 2, 3, 4, 5, 6 red ones. 6 red flags. And how many white ones? 1, 2 white flags. 2 white flags. And we are left with 1, 2, 3, 4 black flags. So what's the ratio red to white to black? Well, it's 6 to 2 to 4. As we can see, the greatest common factor of 6, 2, and 4 is not 1, but in this case it's 2. If it was 1, that means we have the simplest form. In this case we don't have it because it's 2. So we can divide by 2 all of these numbers, all three of them. So 6 divided by 2, it's 3. 2 divided by 2, it's 1. And 4 divided by 2, it's 2. So our simplest ratio will be this one, 3 to 1 to 2. You can try the rest of these. Let's move on to another exercise. Write each of these ratios in its simplest form. So let's do some of these. Like the first ratio is 5 to 10 to 5. Well, we can find the greatest common factor of 5, 10, and 5. I can show you here how to find one of the greatest common factors. We write 5, 10, and 5 here, and start trying to find by which numbers we can divide both of them. If you try by 2, no, we can divide 5 and 5, so we can divide by 2. Let's try by 3. No, none of them is divisible by 3. By 5, yes, this one is divisible by 5, so 1. This one is divisible by 5, so 2, and this one is divisible by 5, so 1. Actually, we can't divide anymore here, so what does that mean? The greatest common factor of 5, 10, and 5, it's only 5. So we shall divide all numbers by 5. We will get 1 to 2 to 1. We solve question A. Let us do solve, for example, D. 70 to 50 to 20. Well, because all of these numbers end in 0, we know that we can cancel all of them. We can simplify all of them by 10. So we will have 7 to 5 to 2. Well, we cannot simplify furthermore because these numbers are coprime numbers. So the greatest common factor of all of these is 1. Let's continue to another exercise. The rest will be for you. Simplify these ratios. 2 days to a week. So 2 days to a week. Well, either we should convert everything into days, either everything into weeks. In our case, it's easier to convert into days. So 2 days to 7 days. Well, this is just 2 to 7. So our ratio is 2 to 7. These numbers are coprime numbers. Being coprime means they have the greatest common factor 1. Let's do another one. E, for example, 2 kilograms to 4.5 kilograms to 1,250 grams. Again, the same, we should either convert everything into grams, either everything into kilograms. I believe converting into grams will be easier. So 4,500 grams to 1,250 grams. Now the only thing left to do is to try and simplify these numbers. So if you try to find the greatest common factor of 2,000, 4,500, and 1,250, let us try and find this one now. So we have 2,000, 4,500, and 1,250. So we can try directly by starting from the smallest one by 2, but we will get some complicated numbers, so it won't be easy to work with those numbers. Let us directly try and divide by 10. So we will have 200, 450, and 125. Then we can clearly we can't divide by 2 because these are even numbers, but this one is not. Because I know that 125 has only factors 5. We can also not divide by 3, so we must divide by 5. Let's see, 200 divided by 5, it's 40. 450 divided by 5, it's 90. 125 divided by 5, it's 25. As we can see, we can divide again by 5, so 8. 90 divided by 5, it's 18, and 25 divided by 5, it's 5. And we cannot divide furthermore. So what does that mean? The greatest common factor will be 5 times 5 times 10. 5 times 5 times 10, which is 250. So we can divide all of this by 250, but why to do that when our answers are directly here? So it's 8 to 18 to 5. This is our final ratio. Alright, let's continue with another exercise. Jane took 2.5 hours to walk between two villages. Philippa took 75 minutes to do the same walk. Write down the ratio of their times. So the ratio is 2 hours and 2.5 hours to 75 minutes. Alright, so we should first convert everything into minutes or into hours. So let's convert everything into minutes. What does that mean? 2 hours and 2 hours have each 60 minutes, and then 1/2 hour, 1/2 hour. Also that one will multiply by 60, and then this will be minutes in ratio to 75 minutes. So 120 minutes plus 1/2 of 60 is 30 minutes to 75 minutes. All right, which is 150 minutes to 150 minutes to 75 minutes. We can cancel both of these by we can simplify both of these by 75, so we will have 2 to 1. All right, let us continue with another exercise. Now Ariana, Sunisa, and Bervi shared a sum of money in the ratio of 5 to 3 to 2. What fraction did they each receive? Alright, we can think like this. If they have some amount of money, they can separate it at least into 10 groups. Why? So if they separate them into 10 equal parts, 5 of those parts will be for 5 of those parts will be for Ariana, and 3 of those parts will be for uh, S, and 2 parts from those will be for B. So, what does this one tells us? I mean, if they had some money, they must separate them into 10 equal parts. Why? Because 5 plus 5 plus 3 plus 2, it's 10. Now, what fraction did they receive? All right, let's assume they had X amount of money. X amount of money. Amount of money. So, Ariana received, well, 5 parts out of 10. So 5 parts out of 10 of those money X. So we can simplify by 5, so we'll get 1/2 of those money. Then Sunisa will have, well, 3 parts out of 10 uh, of those money, of those amounts. So that's 3 out of 10. Well, we can simplify it furthermore. The last one, Bervi, will have 2 out of 10 of those money. Well, we can simplify by 2, so we will have 1/5 of those money. Ariana will take 1/2 of those money, Sanisa will take 3/10 of those money, and Bervi will take 1/5 of those money. Let's continue to our last exercise. A large jar of beads contains red, blue, green, and yellow beads. So we have red, blue, green, and yellow beads. There are twice as many red beads as blue beads. So there are twice as many red. We can write the ratio between red to blue as, we can write red to blue as 2 to 1. There are 5 times as many green beads as red beads. So green to red should be 5 to 1. There are 5 times as many green beads as red beads. There are half as many yellow beads as green beads. So we can write yellow to green. So the ratio yellow beads to green beads will be 1 to 2. Why? There are half as many yellow beads as green beads, which is the same as there are twice as many green beads as yellow beads. What is the ratio of blue to red to green to yellow beads? So we need to have blue to red, blue to red to green to yellow beads. All right, so we have red, blue, red to blue is 2 to 1, which means blue to red is 1 to 2 beads. Now, green to red is 5 to 1. So I can make another ratio which will be totally the same as this one by just multiplying by 2 both of these. So I will have 10 to 2. Why I'm trying to do this? I'm trying to make red and red to be the same, like 2 and 2. So I can connect them. Now, 5 to 1 is the same as 10 to 2. Well, this will be 2 to 10 because it's the opposite, not green to red, but red to green. And then we have yellow to green is 1 to 2. So if yellow to green is 1 to 2, I need to make green 10. So I can make this one 10 by multiplying by 5, so I will have 5 to 10. That means 1 to 2 to 10 to 5. This is our answer. If we would have ended up in some kind of fractions, no problem. Later on, we can multiply all those fractions by a number to get rid of their denominators. And this is the last exercise. Errol, Wayne, Moran shared a packet of sweets. Errol took one half of the sweets. Moran took one third of the sweets. Wayne took the rest. First question is, what fraction of the sweets did Wayne take? All right, so if they had a packet of sweets, let us say it just was 1 minus 1/2 of those minus 1/3. Well, they have same, the common denominator for these three fractions would be 6. So 6 minus 3 minus 2, which is 1 over 6. So Wayne took 1 over 6 from those sweets on the packet. Now, question B is, work out the ratio of Errol sweets to Wayne to Moran's sweets. So Errol had 1 over 2. Wayne had 1 over 6. And Moran had 1 over 3. Well, on previous exercises, we tried to simplify by some numbers. We were simplifying by finding the greatest common factor. In this case, we want to multiply both the numerator and the denominator, so we will get rid of these denominators. Well, we can do that by multiplying all these fractions by extending all these fractions by 6. So I will have 6 over 2 times. I will have 6 over 2 to 6 over 6 to 6 over 3. What does that mean? I will get 3 to 1 to 2. So our ratio will be 3 to 1 to 2. All right, thank you, students. See you next lesson.